Go.
All right. So good afternoon, everyone. So my presentation today will be a small, quick introduction to Rust. Quick few notes. I first started this as an other investigation on my side, so to say, which was experimenting with WebAssembly. And since there were a So I said, okay, it's going to be fun to try to do some front end with WebAssembly with the language that's I can think that's the most opposite to JavaScript. And I'll show you why. But it's pretty much not interpreted. It's strongly typed. There's a bunch of differences. So I started doing that. I didn't get a demo for that, but at least I don't have it here. It's very basic. But I started reading Rust. I said, two for one. I'll learn a new language. It's always nice to stay up some new stuff from time to time. So just play around with some new languages from time to time, and started reading. The bit of code started reading, and so I said, okay, let's do a bigger presentation on Rust itself. So if anyone wants to play with this on WebAssembly, I can show you or can give you a few links after the presentation. But just a quick introduction of the language itself. So Rust. What's Rust? Well, there's the web page. I think they can explain better than I did. It's a language that is pretty much being designed or sponsored majorly by Mozilla. Um, let's go through this very quick so we can go to the fun parts, which is how it works and how you code with it. So, some history. I started as a side project from a Mozilla employee called Rick Moore in 2006. By 2009, a big Mozilla's interest, they started sponsoring it, and he started contributing actively in 2010 and grew out from there. It was first written in OCaml, which is an interesting choice for language, but actually it pretty much tells a lot of the what do you say inspirations for the language. And then by I think 2010, it moved to a self-hosting compiler, and by 2011, it finally compiled itself in version 0.3. Um, so this is LLVM backend, which is being used by a bunch of others as open source projects, pretty fast. And it was the third most loved programming language in the latest Stack Overflow annual surveys. Of course, that doesn't say it's productive or anything else. I'm just showing you the language. I'm not trying to sell the language. I just been playing around with it. Huh? What?
The language is called.
Oh yeah, pretty much. I mean, it's even over Kotlin, which is right now it's pretty hot. It's been in demand. And it's a nice language, by the way. I've been working on it on my customer. It even shows up in the book of Mozilla. Just for you guys, just know, book of Mozilla. It's a little Easter egg where they include some references on their work Mozilla. You can access on that from Firefox. Yeah, I won't go too deep into this. I hope it doesn't offend anyone. It's just a take on Mozilla. But pretty much references that the bees fashion new structure from oxidized metal, which is rust, and proclaim the glories. Which structures? Well, as it turns out, there's a number of people who've been working using Rust. It's a relatively young language. It's had a bunch of work done on it. If you check contributions on GitHub, I mean, there's JavaScript, Python, but Rust is in the top 5 or 10 list. So who used it? First of all, Mozilla. They started sponsoring it because they like the idea of using it for the new servo engine. Servo engine is the one was designed to replace their Gecko engine, which is the one that that Firefox used. If you heard the news this year when they released Firefox Quantum, which was touted as the fastest Firefox they ever had, which is still Firefox, but I mean it's really fast compared to before. Why? Because it's been completely rewritten in Rust. Other people have been using it. Dropbox. They started replacing. They use several things in their stack. They use a bunch of Go, but they started replacing some of the real-time services and systems for their Magic Pocket, the ones that does the streaming of the files in real time, in Rust. Coursera, they use their own services in Rust. Skylight, which is a Ruby on Rails provider. They don't write in Ruby, they write in Rust. And Redux is a relatively new OS. It's a microkernel. It's supposed to be used for Raspberry Pis, microchips, and it's completely done in Rust. So just so you get an idea, Rust is just not a high-level web server language. It's supposed to be generic, but you'll see that what it is pretty much a low-level features. And actually, as we start looking into it, if anyone here has done some work or as in C, you will see a bunch of similar. So it's actually the issues or the use cases that's supposed to cover be pretty much the same rank as C. That's a big thing to say, but there is a project that you're planning to do in C or C++. C. Keep crossing mind. Or at least that's what they'll tell you. So, what kind of language is? So it's compiles binary. You have binaries for several processors, EX86, AMD, Spark. They're doing a bunch of getting the binary to compile to several processors, so it can cover a range of uses. It's static, it's strong typing. It's multi-paradigm, allows both functional and object-oriented, but as you will see, you can see a lot of inspirations from ML and other functional languages. It's just not here, but probably you could have seen himself. There's a bunch of references to stuff like Haskell, for example. You're here, and you are another functional lover. That's true. It's imperative. It's highly imperative. It's done with that purpose, and it's low level. It's designed to be low level to be interact directly with memory. It allows you to do different kind of memory management with minimal memory movement. It allows you to get access to data on the heap. It allows you to references other objects without having to copy and clone whole stacks of memory all over the place. So you can do very good optimizations with it. If for some reason you don't need C, or you just want to reuse a lot of C libraries, which is what a lot of languages do. I mean, what better said, if you want to use Rust, but for example, there are some use cases where you need a C library, well, there have efficiency bindings, which pretty much compile down to straight from C to assembly. So you can just hook it up, you just extend the latency rate, which is your software packages, and you can just do the mapping from the signature from C to Rust, and you just call the functions. It works. It has zero cost abstractions. It has a number of abstractions with generics. Grades will go a bit over it, but pretty much allows you to do that without doing a whole bunch of overhead. Actually, the overhead in Rust, if you want to, it's relatively low. It's just an extensive type system, and these Rust ones run everywhere. You pretty much write the code, compile it, you have the binary, you can run it everywhere. If you need to compile somewhere else, you pretty much just point to the right compiler and you write the binary for whatever processor you want, if you want something more niche. So what does it offer? If you open the Rust webpage, which I did earlier, it will pretty much mention these three things, and these three things are the things that keep most in mind: speed, memory safety, and fearless concurrency, as they say. So speed. I'll open this real quick, if I can. Will be nice. May I? Can you see it? From the it's on this, right?
There you go.
Okay, cool. So these are some benchmarks of different languages against some algorithms that are supposed to know to tax your machine, And here we have Rust compared to some languages, C from the GCC compiler. And yeah, there's some, I think there's some stuff here where C performs better, but we see that Rust is actually performing quite well. If we go to other stuff like Go, we see Rust actually performs pretty well. And if we, yeah, I'm sorry, but I had to do it. That's saying, people. There are other solutions. That's it. Okay.
No, just present it.
Oh, I just need to present it, right? All right. Cool. All right. So speed. It's fast. Memory safety. So I'll go over it just quickly, but Rust is supposed. It's been designed to be memory safe. Whoever has worked with C, they probably, the idea that you can go to access memory directly, references, pointers, it's pretty powerful. But buffer overflows issues, just dynamic references all over the place, garbage data. Yeah, Rust compiler won't like to do. Actually, the Rust compiler is pretty strict. The idea is that you write code that is supposed not to be unsafe, unless you very, very go for it. There are a bunch of unsafe libraries for backward compatibility, but mostly the compiler is pretty strict on what you can do, and even then on runtime, it will not allow you to access them.
But if you do C library?
So C library is like referencing unsafe Rust. I won't go into that. There is a whole bunch of reference documentation called the Rustonomica, which is to write unsafe Rust, which you can do. If you call C, C will do its thing. So yeah, C can be unsafe. So Rust gives you the tools to not be unsafe, but if you go for C, you gotta do. Good thing, I guess it depends on how you look at it. The documentation more than once specifies that it tries to keep the language as lean as possible, gives you a big collection of STD libraries or crates, and there are a bunch more that being created. But the idea is not to rely on Rust like on C, like on Python. You do Python. If you do performance, you C wrappers. Python allows to do that. And it's like like leans on that. Rust, you can do it if you need compatibility, but the idea of Rust that you can replace it with Rust. You don't need to dependency. If there's a library you can use it, then you can just rewrite it and just keep Rust. And fearless concurrency. So the way that memory safety and fearless concurrency happens in Rust, it doesn't have a garbage collector like other languages. Like for example, Go. A lot of people compare Go with Rust because they've seen directives on how they're written. They both based on C. But instead of doing a very fast garbage collector, Rust just says, no, I'll make sure your code is clean. I'll give you the tools to keep good memory management, but I won't use a garbage collector. You will do the memory cleaning on runtime. So for real-time systems like kernels, it's much more, it's faster. And the same system, which is called the ownership system, which I'll go very quickly over it, also gives power to Rust to do a relatively safe concurrency. Concurrency is always an issue in general, but it allows you to prevent, doing disaster with shared states, try unsafe methods like Java sometimes does. As a quick also mention, what also Rust offers to developers is cargo. So Rust comes with a toolkit, which is self-contained in a folder by itself. It's very easy to install and uninstall. And it comes with cargo, which is a mono dependency system. If you work with it, very much looks like comes with Rust toolkits. It's self-contained. You manage a different version of Rust, so you have different Rust versions. You just tell it what version you want to use. Like you will do like with npm or other dependency systems, and you use a toml-based configuration system, which is pretty much like JSON. You just include dependencies. Dependency is not on the create system, you can point to a git repo. creates a log, so you can log the version is actually working for your version. Use Assembler for the versioning of the crates, but the logging is much safer. And it also does some quick scaffolding to create new projects and libraries. So cool. Let's say, okay, that sounds cool. I want to play it, or you convince me. Maybe I'll do it for the next project. What do I need to know? A bit. So if you haven't worked with C, knowing C can help a bit, but it's not enough. There are some features that are like proper for Rust, which you will have to do. I actually started reading and some coding and reading. And I see it from my work. I know some similarity because it's in college. When I started working with Rust, I had to read on a bunch of documentation, like some of the basics. So here we can see references, ownership and borrowing, which I'll go through, lifetimes, which is related to ownership, any extensive type system. If you haven't worked with functional languages, then you might want to give this a too. It's pretty powerful. It has generics, trait system, which allows you to manage traits with sort of duck typing. So you want to set types that do these kind of things. You can implement traits, and traits will work. I'll go in details in a bit. So ownership and borrowing. This is pretty much what it does, or the strength, to say, of Rust, and that's how it manages memory. So what does Rust do? It doesn't have a garbage collector. Cool. So how do I assign memory in free? So you can reserve memory. There are some functions for some of the traits, which is pretty much like malloc for C. If not, you can just declare variables and assign memory for it, of course. And then you have to clear it. So how do you do that? You don't have a garbage collector, so you have to keep track of it. Not why. The compiler will do it for you. So by default, Rust will drop any memory, every volume memory, as soon as it goes out of scope. So you include in a function, including some brackets, as soon as the bracket's over, drops it. Cool. That's fine, but how do I prevent stuff from being assigned, like memory leaks? How do I prevent from it being cleared twice? How do I prevent race conditions? And the ownership system is supposed to address them. So, quick examples here. On the top, on the left, I have A, which is an array. Rust, as you can see, does type inference. It doesn't have dynamic typing. It needs to know the type ahead of itself because it's compiled. But if you see that you're using for some, like calling a method that's only for an integer, it's going to say, okay, it's an integer. If not, you can actually just specify types. Right? So A, it's a byte and assign 8. It's a byte array of 16 bytes, right? And initializing it as a bunch of zeros. Cool. So I assign A to A2. That's fine. So Scholar variables, Scholar types, sorry, which pretty much are like integers, floating numbers, what else? Booleans and arrays. That kind of stuff is kept on the stack. That's very easy. Relatively simple memory to copy, unless you have like huge numbers and you can control that. But like let's say it's a small number. If I do the thing I'm doing on the top left, I'm assigning to A2. So it's going to say, okay, so you can copy these Scholar values in an array. I'm going to copy it into A2, so it actually creates another array. That's fine. And the compiler will like that, and then you can use A and A2. However, if you do the thing on the top right, it will throw an error. Actually, you can see that it's actually a red line, but if you run the compiler, it's going to throw an error. Why? So V it's a vector. Vector is pretty much a dynamic array. Arrays are fixed arrays in Rust, pretty much like C. You have a lot of memory. Record memory there. If you need to be dynamic, it needs to record it in a heap. Then you have to declare vector, which is part of the great standard libraries. Okay, cool. So I'm creating a vector of 1, 2, and 3. Then I assign to v 2, and then I try to use v. It's going to throw an error because v is not owned anymore. What does it mean? So quick movement to the next slide. Usually we have the data on the heap, on the memory, and then we have a reference to it. And yeah, Rust does include references. If you work with C pointers, Rust uses it. But yeah, much clearer system. You never actually get the address in memory. You actually can just refer to it and actually does some automatic referencing. The reference is pretty smart. Anyway, you have the data there, right? And stuff like C, you can like copy the reference to another variable, and then you can both access the simplest in memory. If one modifies it, the other was going to say, well, damn it, I didn't assume I was going to use this. So what Rust does is each variable owns a place in memory. So when we do this, the first thing, what it's doing is saying, okay, v2, now you own this memory, and v clearly says hand. So now v doesn't reference anything; it's a clear variable. So it's going to say, yeah, you can use v, like you assign the memory from v to v2. You're gonna have v and v2 referencing the same thing. You do that, v is gonna like represent like you own it. So okay, but what if I want to create variables and actually do that? Well, it's something called borrowing. So borrowing, it means that you can actually use the reference, which is the ampersand, and say, okay, so if I pass it as a reference, it means, for example, foo, it's borrowing the vector. It's not owning it. If it only owns it, in the main, you cannot use v anymore. If you're borrowing it, you can use, okay, I can get it, do some stuff with it, but v can still access its value, right? However, on the bottom left, it still throws an error. I don't know if you can see it. Why? Because in Rust, all variables are immutable by default. If you want to make it mutable, you have to specify. You have to say, okay, this is a mutable vector, like in the top right, in the bottom right, and say, okay, so this can be muted. Whoa. And then, if you want to modify in another function, you have to accept as a parameter a mutable reference. So I'm saying in full, okay, I want a reference, or I want to borrow this vector, but I want to borrow it as a mutable reference. So I can modify it. And then it allows, okay, you can do that, get it, and you can actually push stuff to the vector, right? Cool.
Can you declare a immutable variable and pass it down to a function that receives a immutable reference?
Good question, and I'm actually going to address this. So, Rust has a borrow checker. We actually keep track of who's borrowing who and who's owning who. The compiler, at compile time, I will use a number of rules to make sure you're not doing that kind of stuff. So the borrowing rules are pretty much these three. You can either, for each variable, each reference in memory, you can either have one or more immutable references to a resource, or just one mutable reference. So you cannot have this vector, pass it to a function as an immutable reference. If you're getting as immutable, it's because you just want to read information from it, and then pass an immutable reference. That's to prevent one function to change data while the other is reading, which calls, consistencies, erases. Like Rust, the compiler is going to say, dude, you're like borrowing these two things. You can do that. So you have to sort it out. You can pass it one or more, like 3 immutable references in a scope, because you're reading from all of them, but then you cannot mute it in that scope. So it's these two rules, and the third one is that references must always be valid. Rust will not allow you to access a reference when the value is already clear. So like you create a reference, then the value is dropped, and then you try to access the reference, and say no. This has to survive until the end of the scope, and then I drop. And that's to prevent, garbage references. You reference a point in memory which is no longer valid. So how does it do that? Rust has a thing called lifetimes. What does a lifetime mean? It means that Rust keeps track of the lifetime of its references. if you're borrowing some data, usually Rust will not drop that information for as long as the reference is valid. So if you're trying to reference some data and need to leave it through until some function runs, you can specify. So it does this thing called lifetimes, which is on the bottom, which pretty much tells, okay, this output from this function depends on which input. Because if I'm receiving a reference and I need to deliver something else based on this, I need this data that I'm outputting to live as long as the input is valid. So Rust usually does that. I'm going to explain a bit, like in the background. But if we're having some functions where it's not clear which lifetime depends on whom, then you have to specify Rust. So for example, at the bottom, I'm saying, okay, the apostrophe A is the lifetime, and I'm saying that the lifetime of X and the lifetime of Y, the output depends on those two. So the output of that function must be valid as long as X and Y are valid. If for some reason X and Y are dropped before whichever value the longest is returning, the compiler will complain and say, okay, now this is an unvalid reference, it needs to leave it true. So a lot of times, you're going to say, okay, I have to write that for all the functions I write. No, there's something called lifetime relation, which pretty much allows you still to keep track of lifetimes, but the compiler will mostly do it for you. So there are a number of rules, which pretty much each input has a distinct lifetime parameter. If there is only one input, then I can assume that the output has the same lifetime. Like if I'm accepting an input, just one, then of course that class will live as long as the input from just borrowing is valid. If there are multiple inputs, but one of them is a mutable, it's a self, because you can actually do object-oriented programming, so you will reference self with a method. Then that is not taken into account because, of course, the method has to the output of the method has to live as long as the object. That's inferred. If a function doesn't apply with any of these rules, like for example, you have multiple inputs and just one output, then you have to specify how the lifetime works. It sounds complex. When you start writing, it's a bit clearer. But the compiler actually gives you a lot of good information about this. So actually, it's going to say, okay, this is happening because of this, and it's going to tell you which points you're dropping stuff, and then it will suggest what you should do. So that's fun. So quick view into the type system. So it has a pretty robust type system. It's pretty much comes from, or it seems borrowing heavily from functional languages. So you have both structs, which I didn't include here, and enums. Struct being multiple, both enum and struct being algebraic data types, struct being product types, while enums are like unions, or sum types. What does it mean? That the structs will actually allow you to put a bunch of keys and assign values, and so you have like this object, like people have in JSON, in JavaScript, sorry, an object. And so you have like all this data packed together as a struct. Or you can have an enum. Enum being a sum type, being that, for example, any data of elements can be either circle or square. If I'm creating an EP address can be either B4 or B6, can be both. And the compiler uses that to do some smart memory allocation. We'll just allocate the largest type of memory for that type in memory. Cool. So what do we use these for? For a bunch of stuff, actually. We can just use them as an enum and assign a number of data types. And we can, for example, like circle, and you can use that as an enum. You can say, okay, circle is either a circle or a square. Or we can assign values to an enum, or tuples even. And those types then are saved as part of the enum, and you will use that as a union. So EP address can either be an array of bytes or a string. Cool. And then you can, when you declare it, you just pass the value. And the way that pretty much extracts value from it is using a smart pattern-based match. Match is like a switch, but it's much more powerful. You can use it to do like basic switch, like uh, get a value and get possible answers, or you can actually match that kind of data types and say, okay, if it's a B4 and extract the input from it, do something with it. If it's if I B is a B6, then I get the input and do something else with it. And there's actually an error to print different stuff. That's okay. Um, Rust also uses this to do um, optional values. So Rust doesn't have null. Rust decided that null is useless, thank God. And so does what a bunch of other functional languages like Elm and Haskell do. They don't have a null, they have optional values. So they have a option with generic. So you say, okay, this is an optional value. What does option do? It either contains some value or non-value. And then any function that provides an optional value, just return an option of something. And then you cannot just use the option. You have to use match to go through it, like we are doing next. And then you can either match with some or none. Good thing about match is that forces you to take into consideration any possible exactly. So you will never have a null pointer exception. You have to manage null or none in this case. And with some, you just extract it. And so it does the same with result. Result is for managing exception. Rust doesn't have exception. Rust, what it has, either panics and just bursts out, or if it's a recoverable error, you manage the result. Result manages either a possible value or an error. So foo and bar, foo can be an integer. You say, okay, 10. So, or it can be an error, and then you do something with an error, and then you can match it and say, okay, I receive a value. Let me get the value. Oh no, there is an error. Okay, just assign it to 0. The underscore is the default, which you still have to implement something. I can just match bar to okay. And the implementation generics is a bit complex, but pretty much generics are sorts of like interfaces in other languages. You can assign traits to struct and enums, and what you say is that okay, if this struct or this other thing must be sortable for me to do sorting. For example, if I try to do that with generics, so I say generics is T. I can do. I'm saying that I can accept any type of data type of type T, and the function of main. But to do that, I need to be able to sort this information. I have to be able, okay, how do you know that A is lower than B? So you say, okay, this data type has to implement ORD. What does ORD do? ORD has a signature, like an interface, that implements how one is lower than the other. And then each data type says, okay, this is lower than the other, this value is lower than this. And then you can say, okay, then I can set any value that is sortable, or comparable actually, not sortable. Comparable, and say, okay, now I can say that A is minor than B. So you can do that with integers, with strings, any new data type that you create, as long as you implement the OR trait, you're saying, okay, this is comparable, and I can actually compare it. And this way is to be able to display it with println. Some data types are complex and doesn't know how to display them, some do, strings, etc. Yeah, so this is really robust. The documentation goes more into it. But it's pretty much all is to create your own types and manage them. Pretty much the whole system of Rust is based on generics and create types, and you can create your own types. You can manage your own stuff where you want. And concurrency, actually had a decent demo to how to implement a web server from scratch, and by scratch I mean like very, very scratch, low level. And I'm here. But I have some samples and documentation. So how do you manage concurrency? You can throw threads. You can access the threads. In Splunk, we have something called closure, which is a lambda, and it allows you to access values outside. But Rust will not allow you to access a V just like that, because if it's a thread, then other threads can also access V, and you have a concurrency problem. So you will Rust will say no. If you want to use bean, you have to include the operator move. Move, what it does is enforces ownership. Okay, so now this thread owns bean. And so you can do the thing at the top, and then if you create another thread that also tries to access bean, it's going to say, no, bean's already owned. You cannot use it. It's invalid. If you want to send and share messages between threads, you can do message. You can use channels. You can create channels and send data from one thread to the other. And that supports for mutex. Mutex being mutual exclusion, so locking your file away. So you can create a mutex of any invalid data type. If you want to access it, you have to log the mutex. If you log it, no other thread can do that. And this pretty much is work for concurrency in Rust. It's very basic and it's by design. That you can design your server however you want. However, you don't have to do that, by the way. You don't have to write a web server from scratch. There are several crates which allows you to do web frameworks. I don't think I'll have time to show you, but there are a few. If you search for them, there's Rocket, there's Gotham. If you just want asynchronous management in a sensible way, there is Tokyo.io, which is a crate that allows you to do asynchronous in a way very similar to Promises. But if you want to write your own, it's very straightforward. So, that was a bit more in depth than I wanted, but I just want to give you some theoretic basis of how Rust does things. It's pretty empowering. Empowering at the level of C, but without the craziness. You're not wondering why some data is affecting some other, why you have buffer overflows, why an array is going over the limit. You know, you go to the reference of the pointer of an array in memory, then you just go all over the array, then you start accessing values that are not valid, crazy stuff like that. C can be fun because of that, but not when you're writing enterprise-like applications. So for that class, you know, it's pretty much just as fast, but the compiler will explode if you try to do some memory and safe things, unless you're very specific that you're saying you want to. The cons. So this was my first, and that's why I can critic my first reaction. Thank you. While writing Rust, and saying, okay, well, I don't really have a strong background in C, and then I went to Reddit, and actually I'm not the only one, and that's coming from other C programmers, and a lot of people say, you know, like Go is much more straightforward. I played around with Go, not as much as Rust, but I did. It's easier to pick up. But I mean, it's both a bless and you know, an issue to say, because Rust will do a lot of complaining during compile time, so that when you actually compile, it's safe. So once you get a hand of how it does things, you know, the whole ownership and references, it's actually pretty clean. I actually liked it. I'll probably do some more tinkering and put up some demos on my repo just to play around with it. But it has a steep learning, even for C programmers. So if you want to do it, you'll have to go a bit through the documentation, play around with it a bit until you get some confidence. The other con which I include here is that it's relatively young, although it's growing up a lot. There are a bunch of crates being posted. They have a rapid release. They release a new version every 6 months, which is automatically managed by Cargo. So it shows some promise. It shows some promise. People are liking it, and it's a bit niche, as niche as C can be. I'm not saying, okay, if you want to write a simple web server, do it with Rust. I mean, Node.js or Python with Flask might be easier. But if you want a strong type language, if you like functional, and you also like speed, then Rust, I think, does pretty good. Sorry for the long intro. I'll set some questions just as a quick reference, though. I just want to show you. A quick demo. Actually, I had like 2 or 3. I left most of those at home. But the main one I wanted to show is this. I decided to do something that managed Python memories. And so I decided, okay, let's implement MD5 from scratch. And actually, it was actually not as painful. It was actually not that painful. This is my only implementation. There's some other. It's actually not very optimized. There are a bunch of stuff. I actually assign memory every time I want to hash a new message. But it works. And I'll post it. And you guys will take a look at it free. If you guys have any questions. Ingest of 95 of text. And she'll actually support a bunch of other binders. Yep, that's it. Any questions?
Carlos.
No.
No questions?
Nothing.
Would you choose it as your first language for a production project?
Depends on as many other languages. So I don't like to stick to a single language in general. So I
You don't like what?
In general, I don't like to say okay, I use this language for everything. So what I would use Rust on something that needs high concurrency, needs to be scalable, and needs performance. So I will pretty much use this. In every other case, I will use C. I would probably take this first into consideration because it's easier.
Okay.
I mean, to maintain probably. And even more actually, I could see myself managing a web server with this. Maybe not my first use case for C. For Rust it will be, but only if I actually need a big, a service that actually does some intensive stuff. If not, I will just implement a simpler language, so I have to teach everyone else about Rust.
I think you usually would choose C. Currently, you would choose C only when you really want is the best performance. And this would suffice too, but this additionally brings you safety. Like the thing that you don't have in C. You have to be very careful programming in C to be sure that it's safe. So it's a very good alternative.
Yeah, that's pretty much what Mozilla probably thought. You don't have to actually think that just test everything and try not to break everything. Rust actually prevents you from doing that and implements some type theory and stuff that languages have been implemented in the last few years, but still with the power of C. It actually does some other cool stuff like the structuring